Alright, here we go. So this is the one that's working. It's number 0. And I'm feeding it 11 volts. This is the one that's simulating having a dead battery. I'm giving it 9 volts, which is not sufficient to run this guy, but it will run this guy. This is our bed connection, and this is the receiver. Now, I haven't written the receiver on the firmware yet, so the way it's gonna work is that if I push the A key, it will try to talk to that sensor, and if I try to push the B key, it will try to talk to this sensor. Now this is the output. It looks a mess. This is all the noise we're getting. This is all the noise we're getting from here. This is actually sending a bunch of noise in. That's intentional. But we can get some signal anyway. So watch this. The way it's gonna work is that you're gonna get a number 4 times when we get a good signal. So caps lock on. And let's start with A. There we go. E140. Now the one that's broken, it's not broken, it's just low power, so it's just gonna give you a bunch of zeros. Here they come. And let's get some more data on the other one. And 143, there we go. And so yeah, there we go, 144. So yeah, this is starting to work. The data rate is very low, as you saw. Part of it is that this guy is actively injecting noise with USB, and part of it is that I am typing the request by hand instead of it doing it by itself. So that's the system, and I'm gonna try to fit this thing into the casing just to see what it looks like. So this is roughly how I want to sit the whole thing. Now the grounding here. Now one thing that's important is that these two circuits have to be mounted at a 90 degree, that way they don't see each other. And still a bunch of noise. And let's see if doing this actually gives me the output that I want. Look like it. Yeah, what I basically did there is that right now I have shorted the 2 grounds using this screw here and this here, which we don't want, obviously. So this guy's gonna have to be mounted on a little cushion. And you can see now that the data is coming in again. Now, when I keep requesting the data, know that it's coming in a lot cleaner. This is because the oscillators are overriding the noise, so we're actually going to get less noise with more data rate up to a point, obviously. You can see here 3165, and the other one is dead, so it's going to give you a bunch of zeros. Let me clear the window so you can actually see it. There we go. The terminal application crashed now, but you get the idea. It's starting to work. This will need to be isolated. This needs at least 11 volts, but if the battery dies, this will still report. It will just give out a bunch of zeros, and I can actually make it an alert instead of, it could be 9999 instead of all zeros. And that's basically the setup. So this guy is going to also have to run on batteries, but with these we can just charge them with a relay, and the relay will switch two battery banks every 15 minutes or so that it will act as if it was connected to the generator. So yeah, that's the system. It took a year longer than I was hoping it would, but it does work.